Immune cells begin in the bone marrow and get released when needed. The cells stay in the plasma until reaching the capillaries. Once reaching the capillaries, the plasma gets sucked up by them. Once the plasma gets sucked up and enters the lymphatic system, it becomes lymph fluid. The lymph fluid now continues on until reaching the lymph nodes on the sides of the vessels. As the fluid enters the lymph node through the afferent vessels and subscapsinus, they first pass through the cortex where the T cells are continuously moving between the nodes, the lymph, and blood to make sure that specific pathogens do not continue in the body. The lymph then continues onto the medulla where agranulocytes and granulocytes reside. The medulla also contains sinuses where macrophages wait for the chance to use their phagocytic properties to consume foreign matter that passes by in the lymph. After exciting the nodes of the ileum through the efferent lymphatic vessels, the lymph continues its journey into the vessels once again. The lymph flows through the vessels until reaching the lymphatic trunk, which is a larger, thicker-walled channel. After entering and leaving the trunk, the lymph finally reaches the collecting ducts. Meanwhile, the thoracic duct receives lymph from the rest of the body. After lymph goes into the right collecting duct, it drains into the right subclavian vein. The subclavian vein merges with the vena cava, which brings deoxygenated blood back into the heart, and the lymph is back in its starting place, which is the blood. And the end of the journey is here. Here we find the evil pathogen, which is defined as a disease-producing agent with an antigen on its surface. The pathogen will now go against something known as the innate defense. The innate defense is the body's earliest line of defense against all pathogens. As seen here, the pathogen will first enter the skin, but is stopped by the waterproof barrier known as sweat. As seen here, a pathogen tries to enter the body where there is mucus. The pathogen then gets stuck to the mucus and is unable to enter the body. Unfortunately, one of the pathogens was able to get by the mucus. Now that the pathogen has gotten past the primary response, it now has to face the secondary response. As seen here, the pathogen tries to work its way farther into the body by going through the eyes, but is stopped by the lysosomes in the tears. Although one pathogen was successfully stopped, another one was able to successfully go through the eye. Once through the eye, it becomes present in the bloodstream where there are many special white blood cells. The white blood cells who are traveling in the bloodstream start to react to the different types of infection caused by the pathogen and bacteria. Now that the pathogen has successfully pushed through the innate defense, the primary immune response activates. The macrophages in the body tissues consume the pathogen due to its phagocytic properties. Then, the macrophage takes pieces of the pathogen and attaches it to their cell membrane. A T cell then touches the antigens excreted from the macrophage and becomes activated. Once activated, the T cells release cytokines, which have many effects. The first effect of the release of cytokines takes place where the infected area is. Cytokines attract more macrophages and leukocytes to the area, which help remove the pathogen. The second effect of the cytokines being released takes place on the B cells. These B cells become activated when exposed to cytokines. Those activated B cells turn into plasma cells, then release antibodies that will clump the macrophages who have eaten pathogens. The killer T cells bind with the infected body cell who have the same antigen. The killer T cell then dissolves the cell membrane of the body cell, destroying the remnants of the pathogen.
They ask you how you are, you just have to say that you're fine when you're not really fine, but you just can't get into it because they would never understand.
Here we see the same pathogen successfully re-enter the body. Upon entering the body, the pathogen is met with a memory B cell. The memory B cell remembers the pathogen due to the antigen receptors on the memory B cell matching the antigens on the pathogen. This lets the body know that the pathogen must be destroyed. B cells then turn into a plasma cell and release antibodies to destroy the pathogen.